This lesson is absolute value equations and inequalities. Solve each equation. If there's no solution, write no solution. Well, we'll notice for this equation, since we have the absolute value of x, that x could actually take on two different values. We could put a positive x in here, take the absolute value, we'd get 7. Or we could put a negative x in here, take the absolute value, we'd still get 7. So x could be either 7 or negative 7. In general, absolute value equations are going to have two solutions. How about absolute value of x equals 2/3? Well, same principle holds as for the 7. In general, we could put in either a 2/3 or a negative 2/3 and get 2/3 back out of the absolute value. So x could either be 2/3 or negative 2/3. Absolute value of x equals negative 1/3, though that's pretty hard to do because absolute values, after we evaluate them, always come out positive. So there's no way that this absolute value is going to equal a negative result. Therefore, there's going to be no solution to this equation. An absolute value always equals a positive, never a negative. We're going to solve the equation. 2 absolute value of x equals 8. We're just going to divide both sides by 2 to isolate the absolute value. Absolute value of x equals 4, therefore x equals positive or negative 4. Again, absolute value equations have two solutions. 2 absolute value of a minus 5 equals 1. We'll go ahead and add 5 to both sides. Then divide by 2. And absolute value of a equals 3, therefore a equals positive or negative 3. Two solutions, or none. In this example, we're going to solve and graph. Absolute value of x minus 3 equals 5. There's two cases. Since this absolute value could equal a positive or a negative value, we have to look at both possibilities or cases. In case 1, we'll let the x minus 3 equal the positive 5. In case 2, we'll let the x minus 3 equal the negative 5. Notice the 5 is the only thing that changes sign here. The absolute value can have a positive or negative result, because after we take the absolute value, it would all be positive. So we could either have 5 being in here, absolute value of 5 equals 5, or we could have a negative 5 be the value of x minus 3, and the absolute value of that would still equal 5. So we have to solve each little equation here separately. On case 1, if we add 3 to both sides, we get x equals 8. On case 2, if we add 3 to both sides, we get x equals negative 2. We can check these. 8 minus 3 is 5, absolute value is 5, so this solution checks. Negative 2 minus 3 is negative 5. Absolute value of negative 5 is also 5, so this solution checks. So we have two solutions. We have 8 or we have negative 2. We're going to graph that. We're interested in two numbers this time, so we'll put two numbers on the number line. Just make sure you put them in the right order here. Negative 2 should be the left of negative or positive 8. It's equal, so we'll put a dot, and 8's also equal, so we'll put a dot. Since there's no greater than or less than, we don't need any arrows. We're just done right here. 2 dots on the number line. Here's one for you to try. Solve and graph absolute value of 4x minus 3 equals 7. Go ahead and pause the video here, give that a try. Then when you're ready to check your answer, press play. Okay, what I would do here is I would go ahead and split this up into two cases. I have case 1, 4x minus 3 equals 7. And I have case 2, 4x minus 3 equals negative 7. Notice the 4x minus 3 stays the same. The only thing that changes is the right side, the side that's not the absolute value changes. Let's solve these one at a time. Case 1, let's add 3 to both sides. So I get 4x is equal to 10, and then divide by 4, and I get x is equal to, let's see, 10/4 would reduce to 5/2 or 2.5. Case 2, if I add 3 to both sides, I get 4x equals negative 4, and divide by 4, and I get x equals negative 1. So I have two solutions here. I have 4 and I have negative 1. So I draw my number line, put on my negative 1, put on my 5/2. I should say I have 5/2 and I have negative 1. Put on my 5/2, and I need to go ahead and put closed dots here because x can equal these two values. There are no greater than or less than symbols, so there are no arrows in my graph. Try this one. Okay, again, I would separate this into two cases. Case 1, is 4x plus 6 equals 5. Notice case 1 is the same thing, just get rid of the absolute values. Case 2, 4x plus 6 equals doesn't change, but the right side I have to take the opposite of, so I get the negative 5. Let's go ahead and solve. On case 1, if I subtract 6, I get 4x equals negative 1, and divide by 4, I'm going to get x equals negative 1/4. On case 2, if I subtract 6, I get 4x equals negative 11, and divide by 4, show that division, divide by 4, x equals negative 11/4. We'll go ahead and draw the number line. Let's see, negative 11/4 is a smaller number than negative 1/4. So we'll put them on in the correct order here. Since x can equal negative 1/4, we'll put a dot there, closed circle, and x could equal negative 11/4. We'll close that up as well. How'd you do? In this example, we're going to solve and graph a little bit bigger equation, more steps here. So let's go ahead. We're going to add 5 to both sides. So 10 and 5 is 15. Negative 5 and 5 zeroed out. Divide both sides by 3. That gets rid of the 3 from this side. It just reduces out. 15 divided by 3 is 5. Once the absolute value is isolated, notice this left side is just an absolute value. There's no more extra stuff. There's no 3 here. There's no negative 5. Now we'll split this into the two cases. So isolate the absolute value before you split into two cases. Case 1, 4x minus 1 equals 5. Just drop the absolute value for case 1. Case 2, 4x minus 1 equals negative 5. And then just solve each case independently. So on case 1, we'll go ahead and add 1 to both sides, and then divide by 4. 6/4 is 3/2. On case 2, we'll add 1 to both sides, and divide by 4. X equals negative 1. We'll take our number line. We'll put our 2 points on there. Negative 1 is smaller than 3/2. And we'll have 2 closed dots because we can only be equal at these points. You try one now. Okay, let's see. I think I would first subtract 4 from both sides. So subtract 4, subtract 4. That gives me negative 2, absolute value of x plus 9 is equal to negative 9. When I divide by negative 2, that's going to clear things up a little bit because I don't want to see negatives over here. I get absolute value of x plus 9 is equal to negative 11. Now let's go case 1. X plus 9 equals negative 11. Subtract 9 from both sides. X equals negative 20. And case 2, I've got x plus 9 equals positive 11. Again, case 1, you just drop the absolute values and write down everything that's left. Case 2, you do the same thing, except you change the sign on the right side. If it was negative, it becomes positive. If it was positive, it becomes negative. And then go ahead and solve each side. So here, if I subtract 9, I get x equals 2. So my number line will have a negative 20 on it, it'll have a 2 on it, and it'll have just 2 closed dots. X can be these 2 values that solve the equation. How'd you do? Here's another example. We're going to solve and graph. Case 1, 2x plus 3 is less than 11. Case 2, 2x plus 3 is greater than negative 11. Notice we're dealing with an inequality this time, not just an equation. So case 1, again, you just drop the absolute values and write down what you see. Case 2, you drop the absolute values, but now you have to change signs. Not only do we change the sign of the number on the right, or whatever happens to be on the right, it might be more than a number, but we have to change the direction of the inequality also. So there's a couple changes here. With the equal sign, you can't tell when it gets flipped over, so who knows, maybe that's being flipped over on case 2 all the time. But with that inequality sign, you can definitely see that thing gets flipped over. So that has to be flipped over on case 2. And then you just go ahead and solve each case individually. So case 1, we're going to subtract 3 from both sides. 2x equals 8, and divide by 2, and x will be less than 4. I said equals, I should have said less than here. On case 2, subtract 3 from both sides. 2x is greater than negative 14. Divide by 2. X is greater than negative 7. Now notice with the greater than and less than, we're going to have some arrows, and we also have to be very, very careful with the word that we're going to put right here. This is either an and or an or, and we have to get this right. And sometimes the graph will tell us what that should be. But if you think about it, are there numbers that are less than 4 and at the same time greater than negative 7? If you can say yes to that, then you can put the correct word here, and. If you can't say yes to that, then you'd have to put an or there. There are numbers that are less than 4 and greater than negative 7. 2, for example, is less than 4 and greater than negative 7. Let's go to the number line. We'll plot our points. We got a negative 7 that came out yellow. I wish that was not. And that's an open circle. We've got 4. That's an open circle. And we're going to graph everything between 4 and negative 7. Notice we are less than 4, but we're greater than negative 7. That just graphs everything between. In general, when you see an absolute value is less than some number, you're always going to be graphing in between. If it's greater than some number, you're going to be graphing outside these points. Try this one. Watch out for the less than. Okay, what I would do, I've just busted into 2 cases right now. I've got 2x plus 1 is less than 8. And I've got case 2, 2x plus 1. Switch the sign is greater than and change the sign negative 8. Here we'll subtract 1 from both sides. 2x is less than 7 and divide by 2. X is less than 7 halves. Here we'll subtract 1 from each side. 2x is greater than negative 9. Divide by 2, x is greater than negative 9 halves. This is an and. I can tell that because the inequality is a less than. So we'll get an and, less than and we'll graph our points, negative 9 halves and 7 halves. We've got open circles because we can't be equal, and we're in between. We can check that. Are we less than 7 halves? Yeah, we are. We're on the left side of 7 halves. That's less than. Are we greater than negative 9 halves? Yes, we are. We're greater than negative 9 halves. Notice these 2 words, less than. Less starts with an L. We go to the left. And L is on the left. Greater ends with an R. Ends with an R, we go to the right, and the R is actually on the right of the word. So that's kind of an interesting little thing that might help you remember which way things go if that's confusing to you still. In this example, we're going to solve and graph the absolute value of 5 plus 2x is greater than or equal to 3. We'll just, case 1, case 2. Case 1, 2x plus 5 is greater than or equal to 3. Case 2, 2x plus 5. 2x plus 5 and 5 plus 2x are the same, so we can turn that around without any penalty. Notice the greater than, it gets flipped over to a less than, and the positive 3 gets changed to a negative 3. Case 2 stuff here. Subtract 1 from both sides, or excuse me, 5 from both sides. So 2x is greater than or equal to negative 2. Here comes my 1. Divide by 2, and x is greater than or equal to negative 1. Subtract 5 from both sides on case 2. 2x is less than or equal to negative 8. And divide by 2, and x is less than or equal to negative 4. If this is a greater than, it has to be an or, but if we think about it, is there any number that's greater than negative 1 and less than negative 4? Well, no, there aren't, so it has to be an or. Go ahead and run our graph here. Negative 4 would be to the left. Negative 1 would be to the right. We've got or equals, so we can close them both up. And since it's an or, greater than negative 1 is to the right. Less than negative 4 is to the left, so we're going to be graphing outside. You go ahead and try one. Okay, again, I would just go case 1, case 2. 4x minus 5 is greater than or equal to 3. Two. 4x minus 5 is less than or equal to negative 3. So add 5 to both sides. On case 1, 4x is greater than or equal to 8. Divide by 4x is greater than or equal to 2. On case 2, add 5 to both sides. 4x is less than or equal to 2. And when we divide, x is less than or equal to 2/4 or 1/2. It's greater than, so it's got to be an or. Can you think of any numbers that are greater than 2 and less than 1/2? You can't, so it can't be an and. It has to be an or. We've got 1/2. We've got 2. We can close circles because we can be equal on both ends here. And since it's an or, the graph goes out. How'd you do? Try this one. Alright, we've got a lot of work to do on this one. I want to isolate this absolute value statement before we do cases. So my first step would be to subtract 5 from both sides. So I've got -2 absolute value of x plus 1 is greater than or equal to -8. Divide by that -2. And when you divide by a negative, make sure you flip the sign. So we're going to flip the sign over, reverse that. Absolute value of x plus 1 is less than or equal to -8 divided by -2 is 4. So we'll go ahead and go case 1. X plus 1 is less than or equal to 4. Case 2, x plus 1. Switch the sign, greater than or equal to, change the sign, -4. Subtract 1. X is less than or equal to 3. Subtract 1. X is greater than or equal to -5. Less than 3, greater than -5. Well, that's an interesting one because we're dealing with an or that's turning out like an and down here. So this is just going to be scratch work here. We've got -5, we've got 3, we're greater than or equal to, we're greater than or equal or less than or equal to. If we're dealing with an or, we have to take everything that works. So let's just do a test here. If what I'm thinking is right, then 5, right? 5 should work. So let's put 5 in. 5 plus 2, or 5 plus 1 is 6. Absolute value is still 6 times -2 is -12. Plus 5 is -7. -7 is not greater than -3, so we just want what's in here. So the moral of the story here is, don't look here to tell you what's going on. Look here to tell you what's going on with and or ors. And notice this says an and right here. That says and. So my final graph, this is all wrong, but notice how you can just check things. My final graph is, let's see, I'm interested in -5. I'm interested in 3. I'm going to close up circles here, and this is an and I'm graphing between. How'd you do? That's our learning target for this lesson. I'll see you in class.